here today at the GDG Cloud event at Campus London. We've had 4 amazing, inspiring speakers today talk about open source, machine learning and AI. If you haven't been to an event or a hackathon before, you should definitely attend. It's one of the most inclusive and diverse community events I've been to. Hopefully no one has fallen over and got bored of my talk, but thank you very much. We've been talking to GDG Cloud about having a hackathon because it would be great to get some coding. They do amazing workshops, but I'd love to just have 2 days of hardcore coding. And I want to get to the YouTube space. I'm sure Jason and Florian can get me entrance into that. They apparently know everybody. They are some really cool dudes. And thank you for, I have like 4 cameras on me, and I understand that each camera adds 10 pounds, so it must be like 50 pounds heavier with so many cameras on me. I feel like a movie star. Yeah!
So, hi, I'm Wolff. I work in the developer relations team for TensorFlow. I have a couple of questions as we kick this thing off. How many of you are using TensorFlow now? Sweet. How many of you saw maybe the live stream of the Dev Summit, even any part of it? Okay, some of you will see some repeated slides. We're going to cover some new stuff too. So anyway, I'm going to talk about TensorFlow 2.0. I should have a title slide. I have to admit I was on vacation last week, so here we go. While I was on vacation, I was in France, and of course, as you well know, there are llamas in France. I'm going to start at a high level, and we're going to get more and more technical. So if we get past the point in which you're like, I don't really understand why we're talking about this, just think of this very peaceful llama, and I'll bring it back at the end. So what's TensorFlow? TensorFlow is a bunch of things. It's a toolkit for doing accelerated math. It's a library that does automatic differentiation. And it's a really popular toolkit for both training and deploying machine learned models. We use it internally, and we've open sourced a big chunk of it. This thing in the middle, saved models, we're going to talk a little bit about those. So saved models, as you can see, is sort of all of this stuff for training models. You eventually come out with a saved model, and then you deploy that saved model to the cloud, to Light, JavaScript, to other languages, whatever you want. You might think of TensorFlow as just something that runs in the cloud, and it is totally one of those things, but this is BodyPix. It's a real-time segmentation algorithm running in a browser with TensorFlow.js, 25 frames a second. There's a community post about this on the TensorFlow blog. TensorFlow can do all kinds of really neat things. TensorFlow enables all this creativity, which is great, but it can be hard to use. How many of you have felt like maybe TensorFlow is a little hard to use? Yeah, okay. It can even be a little bit painful. For example, sessions, kind of confusing. And that thing about starting your queue runners, why do we have that? All that kind of stuff doesn't really fit naturally into regular Python workflows. And the TensorFlow API grew over time, because we open sourced it, I think, December of 2015, or November of 2015. And it grew over time and became more and more sort of elaborate and a little bit more confusing. So you can kind of do everything with TensorFlow, but lots of TensorFlow people still thought it was really restricted. Kind of a way to think about this TensorFlow 1.x kind of series is that it's a bit of a metaprogramming problem, right? You're writing a program that builds another program, and then that program is going to be run on another machine really, really, really fast. Really optimized, and possibly optimized in ways that are sort of unexpected to you. As you work on TensorFlow, the graphs get bigger and bigger and bigger. So this is Inception v3. Each of those little boxes is in an op. It's actually like a whole layer. So there's like 25 million parameters or something in this. So there's lots of advantages of thinking about your machine learning in this kind of model-based thought, but it leads to a lot of issues with usability, especially around visibility into what the model is doing and debuggability. So we learned a lot since we published TensorFlow, and one of the things we realized is that people need rapid prototyping, need easier debugging, and that there was a lot of clutter. We had like a lot of different ways to do the same thing. Yeah, everybody's nodding back there, yeah. Not really very clear guidance on what's the best way of doing something. So we're addressing these issues with this new version of TensorFlow, which you can try right now. And in fact, you can try it in Colab. We have the pip install thing for installing the preview. Many of you have participated in design reviews for all these features, and we really appreciate that. Some of you have already tried using this and given us feedback, which we also really appreciate. When we created TensorFlow 2.0, the biggest focus was usability. We've adopted Keras as the high-level API for TensorFlow, and we've integrated it very tightly into Keras gives you sort of a clear path for building certain classes of models and deploying models with a very well understood API. And we know that it gets people productive and gets them started fast. TensorFlow has a complete implementation of Keras, but we went a little bit further because originally, I don't know, some of you probably know this, Keras is actually was originally a separate API that was like wrapped around TensorFlow, and you can still use it that way. But we actually pulled TensorFlow also into tf.keras, which allowed us to make some differences and some optimizations in there, and also give you access to like all of the stuff that's inside TensorFlow instead of just the stuff that's inside keras. The other big change in TensorFlow 2.0 is the switch to eager execution by default. Eager execution gets rid of this sort of dissonant, like I'm making an op and then later I'm gonna like hand that op to an accelerator and then I'm gonna put some data inside that op and then data's gonna, you don't have to do that anymore. You can just say, hey, I'd like to have these two numbers, and you get a response right away. I just want to say, I mean, eager is actually really awesome, and I realize I'm the developer relations guy telling you that this new feature is really cool, and so that's not a particularly believable thing. But I actually started using eager at the very beginning when we were first putting it into like pre-alpha internally, and I found it really sped up development. You just have to use your basic Python skills to solve problems. You get to debug using print, which I really needed, all that kind of good stuff. Especially like setting up new pipelines or connecting pipelines to models. It's much easier, much clearer, and much easier to just kind of feel your way through that bit by bit, rather than building this entire big model and throwing it into and then trying to run it inside a session later. So we've taken the opportunity to clean up the API quite a bit. TensorFlow had a lot of duplicate functionality. It was confusing, especially when those duplicates kind of like looked the same but behaved slightly differently. That was probably a problem. We reorganized and consolidated the API. We made sure the API looks and feels consistent. This is not also about just TensorFlow. TensorFlow is this big ecosystem of tools, like I showed you at the beginning. And we spent a lot of time trying to align all of these interfaces together. So we've defined exchange formats that kind of work everywhere, and we're trying to make sure you can travel smoothly through all of these different pieces. So even though we removed a lot of clutter from the API, TensorFlow 2.0 still retains and expands the flexibility that you've expected from TensorFlow. We've created a more complete low-level API, which exports all the ops that are used internally inside the raw ops module. We have inheritable interfaces for crucial concepts, such as variables and checkpoints, and we'll talk about layers. We'll talk about that in a little bit in a minute. And that means people who are building their own frameworks on top of TensorFlow have access to all these different pieces. We also know that upgrading is never popular, so it's especially true for major version upgrades. We're writing migration guides right now. We've got the start of it already on the website. We're working on making videos and documents to help you figure this out. And we're also, just like we need them for ourselves, tools to make this transition easier. So TensorFlow 2.0 actually comes with a compatibility module, tf-compat v1. tf-compat v1 contains the complete 1.0 API. So if you have some like legacy op that you really need, it's still there. And you can use it. So we're not like removing any functionality, except tf-contrib. tf-contrib was a weird thing where we kind of piled up a whole bunch of code that was like we kind of liked, but we didn't like enough to promote it to be part of the API, and then we didn't really have rules for like when it left contrib and a bunch of other stuff. So we now have experimental, which is a little bit more formal, and we don't no longer have tf-contrib. And we come with this script that can convert TensorFlow programs to be compatible with 2.0. And in fact, there's a guide that goes with that that's on the website that you should totally check out. When you run that converter, it's still going to be very V1-y code. And so from here, I'm going to talk a little bit more about what it's like to write like pure 2.0 code. Like I said earlier, a couple of years ago, we decided that Keras was going to be our high-level API. Keras is a specification for model building, works with multiple machine learning frameworks, and it has a shared language for defining layers and models and losses and optimizers and all that kind of stuff. And like I said, we've implemented it inside TensorFlow as one of our high-level APIs. Keras is really great if you're new to machine learning and you want to play around with it. So this is what tf-keras looked like in 1.x. You can see we're making this sequential model with a bunch of layers, and then we're going to compile it and specify what our optimizer and loss is going to be, add some metrics. Then we're going to call fit, which actually does the training, and then we're going to evaluate at the end. So now I'm going to turn this into 2.0 code. It's exactly the same. So the question you might ask is, what's different here? And what we've done is we've done a lot of work to integrate Keras with all the other features TensorFlow has. So this builds a graph, actually, and we're going to talk about sort of all these things. Like when you say sequential, you're just like smooshing a bunch of layers together, and out comes a graph. But you can also tell it to run eagerly, and then you can step through it as you're going and run the Python debugger. Likewise, so this same model definition for 1.x will now run eagerly without any changes. If you, and this is just general in Keras, if you find that the default set of layers aren't working for you, it's pretty easy just to override, and make your own layer. You just have to define a couple of functions. This is actually how the community repository for TensorFlow add-ons operates. They have like really specialized, complicated layers and optimizers and so forth. And they're just building on top of these base Keras classes. And if like layers isn't the abstraction you want, you can override model. And now you have a Keras model, but you've now overridden it with whatever you want the actual behavior to be for calling and initializing it. So we can define very arbitrary model architecture rather than just stack layers. Or you can kind of do whatever you want. This is a snippet from the Sonnet 2 talk at the Summit, where we're actually building on top of Sonnet module. Module is itself built on top of another abstraction in TensorFlow called TF module. TF module is a superset, is a parent class of layer. So it's kind of a bag that holds variables. It comes with namescoping and a bunch of other stuff that helps visualization. In this case, this isn't even a layer. This is actually an optimizer. But nonetheless, you can, whatever you need to build, you can build on top of this stuff. At the beginning, I was like, hey, we simplified TensorFlow and it's all streamlined. And here I just showed you like 4 different ways of writing TensorFlow code. So it sounds like, well, I'm not. And I didn't even mention estimators, and estimators are still there. So it sort of sounds like maybe we didn't simplify this. But it's actually, at least from my perspective, I don't think that's true. The key is that all of these different ways of writing TensorFlow are sort of variants of the same way. When you're writing TensorFlow, the first thing you do is you go and get a model. Even if you're pulling the model off the rack, or you're getting a pre-made estimator, or you're writing your own, you start and you work in eager for a little bit, and then you're like, okay, I got to get all my big data pipeline going. So then you go and you write a little bit more eager, trying to make sure that when you load the data, it's actually loaded and it's not all zeros. I'm not speaking from experience at all. You're checking it and you're looking at it, make sure it's the right size and all the types match, and then you kind of smoosh those things together, and then you kind of run it for a little bit with test data or a subset of your data to verify you're getting results. And at this point, you might be running just on CPU or on one GPU that you have plugged into the box under your desk, not really focused on speed. But as soon as you get it working, you're tired of listening to your laptop CPU fans going. So you're like, okay, we should actually make this faster. And actually, in eager, it's still going to be pretty fast, depending on what your model is shaped like. We're working on making eager perform on all sorts of different platforms, like TPUs and CPUs. And as long as your code, as long as your model can stay mostly on the GPU before it returns, you're going to see it act about the same as it would without being eager, in graph or not an eager. Because ultimately, it's how long it takes to multiply all the numbers together. But if you have a lot of side trips going back and forth between CPU and GPU, you're going to see it be a little bit slower. I just talked about graphs again. So now we're back in thinking about this metaprogramming problem. We still, even if we're writing all this code that runs eagerly, we still ultimately need to save out a model at the end, right? We need some way to say, this is my model and this is the code. This is this unit of functionality that I want to push out to serving or Light or JavaScript or whatever it is. We also need graphs because we want to use accelerators. This is the TPU v2 that's water-cooled, super fast. It's very difficult to to have enough data. Well, anyway, that's the newest one. Super accelerators are what make all this ML possible. And again, if you want to deploy models in places where Python isn't available, you obviously can't depend on eager. You ultimately need a graph. So we love graphs. But you don't actually have to have your whole thing to be a graph. You can actually subgraph pieces of your computation that need to be fast, and then leave the other stuff running in Python, so it's easier to debug and easier to run. Don't forget your data pipeline. The more of your data pipeline you can do in the form of tensor operations that you can put inside graphs, the better it can be. So I'm like, hey, I can just take arbitrary Python and turn it into a graph. How do I do that? Well, we have this thing. It's called TF function. The joke is, with TF function, you never have to write the session again. For those of you who write a lot of TensorFlow, you're like, oh yeah. in this case, to create a function, you use TF function, you pass it a Python function. And then we run that Python function once and build a graph internally for what that thing does. And then once you've done that, a function just it acts like a TensorFlow op. You can now call it eagerly or inside a graph and get results. So here we've turned TF function into one of these things. Then we try to add 2 tensors and we get results. You can also run functions with large ops in it. So if you want to stack convolutional layers, like I said, that's about as fast as eager. But functions that have lots of small operations in them, like an LSTM cell, are going to be much faster because you're turning that all into a graph, and then you're not have to go back and forth between the CPU and the GPU. You're not have to go back and forth inside Python and be limited by the global interpreter lock and all the other stuff that goes on there. We want to make TF functions as usable as Python functions, so we specialize them based on their arguments. So I pass into a float, I'm going to get float results back. I pass an int, I get int results back. But you're actually secretly making, and I didn't technically review this thing with the rest of the team, but my understanding is you're actually building 2 different, you end up with 2 different subgraphs that take different types. Oh, right. Another thing that's kind of awesome about using functions to hold on to your pieces of your graph, instead of the way we used to do it, where we had a big session and we just had a big soup full of variables that had names on them, is that we can actually locate the variables next to where they're being used, and then we can actually verify that it's right. Anybody know control dependencies? Yeah, well, you're lucky. Control dependency is how because the trick is when you have a big graph, and you pull on the end and you say, hey, give me a value out, it looks back up the graph and decides what do I need to run to find out this result. And the problem is, you don't know what order that happened in because the graph will just make the best choice. Yeah, I can see some nods out there. You know what I'm talking about. Makes debugging really hard. With TF function, we automatically add these control dependencies for you to ensure that the code is happening the way you expect it to. But we try to avoid any unnecessary sequentialness to your code. So this should be performance invariant. Another thing is global variables initializer. One of the problems with all these things, we write all these models that manipulate variables. How do we make sure that they're used, created and used correctly? Here we have, we don't need to write this anymore. So as long as you use non-ambiguous usages of variables, they kind of do what you expect them to do. So if you define this variable, it's initialized with 1, and that's what you thought it was going to do. And if you've ever used the initialize all variables, you totally know that sometimes you haven't initialized the variables and weird things happen. It's also okay to create variables as long as we can determine that your function creates a variable only the first time it's called, which actually covers most of the use cases of variables inside training models. Also, control flow. If you've ever done control flow in TensorFlow, that was the very first thing I tried to do, was try to ingest a bunch of JPEGs and try to figure out if they were landscape or portrait. And it was like a week. I don't recommend that. TFCon and while are hard to use. But with TF function, we just can wrap it up and it will just turn into control flow, correctly built TFCon to TF while. We do that with a subfunction of TF function called autograph, which is sort of a Python to Python compiler that we've integrated into it. It simplifies all this graph building. Autograph has a ton of functionality, but what's enabled by default is this conversion of if, for, and while, and it only does it when it can see that the operations are in tensors. So what you saw is pretty magical looking. To explain this a little bit, if you think about it, TF can get a lot of idiomatic Python by overloading operators. Right now, when you just say like tensor plus tensor, we've overridden plus and subtraction and all the rest of that stuff. So it just does tensor math for you. But Python doesn't let us, only lets us overload a couple of different operators. Things like control flow constructs can't be overloaded. So here, if you have this conceptual overloading, we can define, if condition A, else B. We'd really like to remap this, possibly, to use TFCond. This is kind of what autograph does. It lets us override these fundamental constraints, and we do that using like reparsing the AST inside Python to kind of unroll everything and desugar everything, so all of your like Python list comprehensions get unrolled and turned back into while loops. So then the autograph can operate on them and turn them into TF while and TF cond. There's a lot more to talk about with Autograph. I love it. We can talk about it a lot. But we have documentation online, and you can talk to me later if you want to know more about it. So the big takeaway here is if you never loved session run, or control dependencies, or global variables initializer, or tfcond, or tfwhile, they're all gone because you have tf function. And in return, you can take one of those tf functions and save it out as a save model. And all the variables, because they're attached to the function, get saved out with it. So that's really cool. And then you can pass these different save models around to all these different other subpieces. Basically, going back to all this, when you're writing TensorFlow, first thing you're doing is you're getting your model working, then you're getting your data flowing, then you verify that you're actually getting results, then you add some tf function now, make it fast, and then maybe you add a distribution strategy to put it on a whole bunch of different machines at the same time. I totally didn't talk about that, but that's absolutely a thing you can do, and now you're awesome. So just as so that's the end of my talk about 2.0. There's lots more to talk about. I just want to follow up and mention that there's going to be TensorFlow World this fall. We give a space for the TensorFlow community to connect with each other. Co-presented with O'Reilly, as well as us, and it's in October. Santa Clara, which is close to where I live at least. I hope you can make it. 4 days celebrating the TensorFlow ecosystem, training, tutorials, talk, vendor presentations, all this kind of good stuff. And most of all, giving people a chance to talk to each other. We talk a lot about TensorFlow to the public, but what we really want is, I love the talk tonight, talking about how to use the object detection API. These are the sorts of things that we'd love to hear. Meanwhile, if you want to try out all this stuff about eager and tf function and everything, check it out tensorflow.org/alpha. That's where we put all the alpha docs right now, and it'll be fun.